All right, so again, we're starting a new chapter. So in this particular chapter, what we will see is all about the denominator when we try to figure out the force of mortality. So that is exposed to risk, right? The lives that are exposed to risk whenever we observe a particular event. And throughout these chapters, we have seen the event of interest to us is usually the deaths of people. And again, so there are certain issues, some practical issues that come up in between when we try to figure out the force of mortality. Okay, so let us say, we'll see an example first. And let us say that I observe deaths of people. So there is one department in the insurance company that records all the deaths that happen. And there's some another department that records the premiums that these people pay annually. And that premium will be one source for us to determine which lives are exposed to risk. Right. So let us say that these two different departments do not use the same age definition. So what I mean is, let us say my deaths get recorded as age last and my exposed to risk gets recorded as age next. Again, what do I mean by age last and age next? So not every time we know a person is precisely 48-year-old, right? There has been some time passed. So let us say if your birthday is in January, but now you are in April, then you can't possibly say that you are 28-year-old. Let's say if you are 28 in Jan. So again, whenever I say that, if you ask me how old am I now, I'm much more likely to say that I am 22 because my birthday hasn't yet occurred in this particular year. So what I'm quoting now is my age. The age that I turned out to be during my last birthday, which was last year. So that will be age last. So again, let us say now, let us try to generalize. So if I have x minus 1 here, x here, and x plus 1 here. Okay, so this can be 22, 21, and 23 for me. And now if I want to figure out what is my age, at some point in time here. So I'm more likely to put that my age is x. If you ask me my age here, I will say my age is x minus 1. If you ask me here, I will again say my age is x minus 1. So up until I attain the age of x, I keep telling people that my age is x minus 1. So what happens is, from this, up until this, I say that my age is x minus 1. Then from this to here, I say that my age is x. So even though you precisely turn x-year-old on this day, you claim yourself to be x-year-old throughout this period, right? And that will be the definition of age last, where up until you attain another age, you keep quoting the last age that you have achieved. And now talking about age next. So let us say again, we'll draw the same number line. So I have this x minus 1 here, x, and x plus 1 here. So now if I were to say what is my age at this point in time, I will say my age is x. Here, I will say my age is x plus 1. So now what I do is, starting from here up until here, I say that my age is x. And then starting from here up until here, I say that my age is x plus 1. So age next, when you're using the definition of age as age next, this is what you say yourself to be in. So let's say if you are somewhere here in between x minus 1 and x, you claim yourself to be of x-year-old. So if you ask me now, I might say that, I'm x-year-old. Once I have already passed my x minus 1th birthday. So these are generally two definitions of age. So again, there is one more definition of age, which goes by age nearest. Now in age nearest, what you do is you have, let's say, x here, x plus 1 here, and x minus 1 here. So what you say is you precisely divide this, okay? You precisely divide this in half. And after this, you will say your age at x. And before this, you see, you'll say that you are age at x minus 1. So you see which one of these you are nearest to, and that is what the age you will quote to other people who will ask you about your age. So if you see from this point in time till that point in time, you will say that your age is x. And from here on, you will say your age is x plus 1. And from here, you will say your age is x minus 1. Does this make sense to you guys? So let us say if now my insurance company, what they do is they record deaths of people and they record exposed to risk for people, right, who pay them a certain premium. But now when they're recording the premium of, let's say, some person at this point in time, the age that this guy is going to quote to these people is X. And the age that this particular guy, if he were dead, would be quoted as X minus 1, right? So there is this discrepancy between the age. And this is what we will try to adjust in this particular chapter. So first, we are saying that the age definition used by these two departments, if it is not the same, then we'll have to adjust certain things. So that if a person is dying, let's say at this point in time, and is getting recorded as X minus 1 aged, then that would be his age, let's say, if he were not to die. And if we were to record that particular guy in exposed to risk at that particular point in time. So we'll have to see how we can make this particular correspondence easy. So we expect basically that if a life is getting recorded as being dead or being exposed to risk, then the age definition, even if it is different, how can we adjust either of these age definitions to correspond to the other one? So let us say maybe I do some adjustment in here in exposed to match this particular age with this particular death. So I see that for all the times when I'm age at X minus 1 in death, I am call myself age at X in exposed to risk. So what I can do is whatever I have in my record for exposed to risk. So let us say if a person if a person, so hypothetical, let's say, if a person is dying at this particular point in time, so my exposed to risk, so I'll be recording that in my death department, let's say. So here I will see that this particular person is aged 23 when this particular person dies. So that is my age when this particular person is dead. But now let us say if the person is not to die, and if the person pays their premium, so that will go in the exposed to risk, right? Exposed to risk at this particular point in time. So according to this particular data book, you will see that this particular person has been recorded by the age of one more than that you recorded here. So if here you have recorded them as 23-year-old, here you will have recorded them at 24. So what you do is, every time you want to figure out your force of mortality, you want to subtract 1 from this particular ages. So you will subtract 1 here so that this X minus 1 corresponds to this X minus 1. And then you will count the number of lives alive at that particular age. So because your force of mortality, you expect it to be dependent on the age. And again, just because of the time duration being different for the classification of ages, this makes it a bit convoluted for us. And that is why we try to do some adjustment. And we'll see that it is way much more easier for us to adjust exposed to risk than to adjust the death. And this particular thing that we are trying to do, so if the age definition of death and exposed to risk matches, so that will be known as, not exactly the age definition, but if at any time I look at the age in exposed to risk for that particular same person matches the age at the same time for the death, then that is known as the principle of correspondence. So again, this is just a big heavy name. So this is actually known as principle of correspondence, and this is what we want our force of mortality. So whenever we try to figure out the force of mortality, this is what we expect at least. So this is known as principle of correspondence. So the corresponding ages at the same time for the deaths and exposed to risk data should be the same. And if this is not the case, then we see what we can do. And that is the whole concept of this particular chapter. Okay. But again, I mean, apart from these ages being different, if let's say the age is same, then there is it's very easy for us to figure out how much of life is exposed to risk and what time each of these lives have spent being under the observation, which is what we used to define as waiting time in the previous chapters, right? And we tried to study various models. So we studied POSWA model, we studied the Markov models, and we saw two things, right? We studied one, which was EX, which is the initial exposed to risk. And we studied something else, which is EXC, which we define as central exposed to risk. So this is my initial, and this is my central. And both of these are the way I can denote my exposed to risk. Okay. So these are basically two general definitions that I have. But now what we will see is what kind of exposed to risk do we care a lot about? So if I'm talking about the central exposed to risk, this is mostly used in multi-state POSWA model, multi-state or POSWA model, which we have already seen. And if I'm talking about the initial exposed to risk, this is much more applicable in the binomial kind of models. And there is one assumption when we're talking about the initial exposed to risk. What we assume is that the deaths are uniformly distributed. So we assume that the event or risk is uniformly distributed throughout the time, throughout a unit time that we are looking at. So between two initials, we expect that the deaths are, uniformly distributed. So let's say if you observe one death in a whole year, you will assume that that happened precisely in the middle of the year. So in June, let's say. So that is what you will have in the initial exposed to risk. But again, when we're talking about central exposed to risk, we do not make these kind of assumptions. And this can also be used, let us say, if you're not only looking at death in general, but let's say if you have 2 or 3 other kind of decrements. One could be retirement, one could be death. And if you have multiple decrements, then what is much more helpful is central exposed to risk. So again, throughout this whole chapter, we will try to figure out a way to accurately estimate central exposed to risk. And why? Because that will help us in a way to determine the initial exposed to risk, if you care about that. And it will help us in a way, after all, to figure out the force of mortality. So again, we have already seen that my mu of x, which is just the force of mortality. So the instantaneous force of mortality, I can denote as dx upon exc. So dx will be given to you, and exc we are going to look how to figure out in this chapter. And if you know this too, then you can easily figure out your force of mortality. And that will happen in the case. And the other thing that you might generally want to figure out is your qx hat. And this will normally be, dx upon ex. So again, as we know, this qx represents for the whole year, right? So here I have the initial exposed to risk in the denominator, and here I have my central exposed to risk in denominator. So you can still question, right? Why do we want to figure out central exposed to risk? If I want to figure out qx, I can just figure out my ex, and then I'll have my q hat of x. But if you see, If you want to figure out the initial exposed to risk, this is way much more complicated because there is so much of adjustment that you will have to do. And again, this doesn't quite, get altered due to decrements or increments. This proves very tricky in terms of calculation. So we stick to calculating central exposed to risk. And once we have that, we can figure out mu x, and then we exploit the relationship that we know. So we also know that I can write my qx as 1 minus e raised to minus mu x if I'm assuming a constant force of mortality. So I can exploit this particular definition and relationship between q and mu once I know this mu to figure out this q. And once I know this q, I can work backwards to figure out my ex using exe. But again, we don't have to do that because we have already seen before that there is one very good approximation, right? Which is that your initial exposed to risk is nothing but just approximately addition of central exposed to risk to a half. And this will give you your estimate of initial exposed to risk from directly just knowing your central exposed to risk. So this is the background. And what we will try to do in this whole chapter is try to figure out central exposed to risk. What is the waiting time that these lives have spent under particular observation at certain age that we care about? Okay, so again, before we do this, there is one thing that we need to highlight is the importance of homogeneity. So again, whenever I'm trying to figure out the rates of mortality for a certain group of people, I expect them to have similar characteristics. Because if, let's say, I'm looking at a group of men and women, so we have a mixture of men and women, and some people smoke and some people do not smoke. And if I only figure out one rate of mortality for all of these people, which is, let's say, some number X, then can I say that my mortality rate for a woman who smokes is X and my mortality rate for a man who does not smoke is also X? I mean, that would be absurd and we might not think that they would be the same either, right? So sometimes we have to chop our total sample into some groups, and those groups we expect to be homogeneous. So maybe we divide our population into 4 males who smoke, males who do not smoke, females who smoke, and females who do not smoke. And thus we see that we have 4 groups which are more or less homogeneous, at least on the terms of parameters that we classify to be important, which is gender and whether they smoke or not. So sometimes this is easy, but other times this still might be very difficult. And then there is again, one thing you can do is you can separate this, but there is some cost in addition to trying to create these homogeneous groups. So one is, let's say, if you over divide your population, then there will be too little data in one particular subcategory, which is homogeneous, for the techniques that we have studied to be, very, very very good approximation. And that will create a problem because sometimes if the population size is not large enough, then even though you have a very precise homogeneous group, the estimates that you will figure out will not reflect the actual number. So that will be one thing. And the other issue that might come up is the cost of collecting the information. So most of the times the forms that we submit are collected for marketing reasons or administrative reasons. And there might be some cost associated to even keeping all of the data about one particular person. So not every time you can figure out each individual's characteristics. So you will have to determine the order in which these characteristics matter to you. Not all of the characteristics will be as important, at least for the thing that you are trying to care about, which might be death in our example. So again, there are just various examples given in your book itself about the kind of subcategories you can divide people in with respect to. So one ground of division could be the gender, the age, the type of policy that they take out when they are trying to insure themselves, whether they smoke or not. Then the duration in force. So by duration in force, it means, how much of the time they have already spent being here. And then there might be other various characteristics that you can again divide your population on. So it could be, geographical location, where are they located, and if there is certain risk associated with people living in a particular region or not. And then about the diseases that they might have, about the policy size, about the level of underwriting, about the sales channel. So when I say sales channel, sometimes you might have, come across these forms wherein they ask you to fill, how did you come to know about us? So they'll give you other options, LinkedIn, Facebook, newspaper, word of mouth, our website or something, and so on. So that is normally termed as sales channel, because again, it matters a lot. So if you took over there, let's say that you came from LinkedIn, then there will be some assumptions made about you, that you are an active job seeker on LinkedIn, and that is why you came across them. And basically, if you come across a particular company where you're trying to apply from LinkedIn, then they will assume that there is a good chance that you might have applied elsewhere as well. And let's say if you click on the website, then they will know that maybe this person was, they're very keen on internship. That is why they were checking our website. And that is how they got to know about our opening. Or let's say if you just click on a newspaper or something, then they'll judge you in that way. So there are these certain assumptions made about the way you get to know about these particular people. So sometimes, let's say if in the case of insurance companies, if you get to know about a policy through reading in a newspaper, then they will make certain assumptions about you. And if you get to know, let's say, about the particular policy because of some distributor or some known person of yours, and they'll make some certain assumptions. And this might be just one factor that some people might consider helpful in determining your mortality or something else. So sometimes what might also happen is, let us say if you say that you came to know about certain thing from a local newspaper, then you know that highly affluent people do not tend to read local newspapers. So if that is the case, then you will have some idea about the socio-economic background of this particular person just by knowing where did this particular person got to know about your program or your policy. So that might be one thing, but again, this is not true for every case, and this might not be that helpful in determining things every single time. And we should again be aware of the cost that there might be. And I think so all the divisions that we create will be highly reliant on the fact that we have enough information about all the people. And I think this, at least in this century, people are talking about, data being the new money and so. And I think, yeah, that is true, because your data tells a lot about your choice, your preferences. And sometimes, all of these products, all of this marketing advertisement that happens, it's just a play of psychology. Even though you don't need some product, they will market it in a way that you will feel as if you want that product. And I think that's just basic human nature that they are trying to exploit. And because we humans are predictable and we all know it, some people just try to figure out a trend and a pattern, and they make loads of money out of it. Okay, so I guess, I don't know, but yeah. So coming back to our chapter, what we are now trying to do is determine an accurate estimate for the force of mortality. And again, whenever I'm talking about force of mortality, why do we care about the force of mortality? Why does the insurance company need to know how likely you are to die in a particular time or at a particular age? Because they want to figure out what premium they should charge you, right? So let us say if you do not have variety of estimates for force of mortality for different categories of people, you might charge each one of those people the same premium. So let us go back to the basic example of male, female, smoker, non-smoker. So if we have these four types of people, and if we have these four characteristics imbibed in the whole population, then what do we see? Let's say if we charge each one of them, so by four characteristics, I mean the combination of these. So male smoker, male non-smoker, female smoker, and female non-smoker. If we have these four characteristics in, so then if you charge the same premium to each of these four people, what's going to happen? I mean, you will in a way balance out, right? Because ideally, as we all are aware, if people tend to smoke, then their mortality rate tends to be higher, at least compared to the people who do not smoke. And again, I don't know what kind of relationship exists between male and female. So we'll try to ignore that and we'll just stick to one thing. So we assume that the people who smoke are more likely to die than the people who do not smoke, given that the rest of the characteristics for these people are exactly the same. And now if an insurance company charges the same premium to both kind of customers, so smokers and non-smokers, each of them pay the same premium, then it is kind of beneficial for non-smokers because they don't have to pay a higher premium, right? Even though they smoke and they have a higher chance of being dead, they pay the same premium as the people who do not smoke. And for people who do not smoke, they have to pay a higher premium. Why? Because even though they do not smoke, and because because of the fact that they do not smoke, they have a they still pay the same premium as the people who smoke. So they might look for other alternatives and they might go to other companies. And that is what happens. So let us say all the firms try to collude and they say that if any person wants to get insured, then you will have to pay the same premium whether you smoke or you do not. But then there will be some company who will think that maybe if I lower my premium for the people who do not smoke, they will more likely come to me and I will, my business. So they will do that, and then again the cut through competition and all of the stuff will happen, and ultimately you will reach the equilibrium. But in the equilibrium, you will see that the premium for the non-smokers and the premium for the smokers will be completely different, and they will not be the same. So generally, premium for smokers will be higher than the premium for non-smokers. And if that is not the case, then maybe a company on an average doesn't change their profit. But again, with respect to the other companies, that might drastically impact its business. So again, I think, this chapter is in a way important because there are, this is very, very practical issue that each of the companies do face. So how do we adjust for this thing? So first of all, we will try to have a look at if we can figure out the exact exposed to risk. So to figure out exposed to risk, all we need to know is when did the observation enter our observation period and when did the observation left. So let us call the subjects. Let us call them subjects. So let us say when does my subject enter the observation and when does my subject exit the observation. And if we see, the entry points could be any, right? So let me just pull up the book. And if I see here, yeah. So if you want to figure out precisely what is my exposed to risk, you need the information, right? So again, let us say if you are trying to figure out exposed to risk of people aged X to X plus 1, then you will need to know their date of birth, right? The date in which, the date from which you started observing them and the date at which you last observed them. And then you can compute your central exposed to risk precisely. But again, now, to figure out the date at which they entered into the observation, you have three choices for you. So one could be the date of entry. So not every time a person aged at X will be entering the study precisely when they turn to be X years age. So what might happen is, let us say we declare and we say that every person who is aged 55, we will include them in the study. So sometimes those people might be, 55-year-old and 3 months old. So you might still take them if you are considering age last birthday, which is when even if they are 55 and 12 and 11 months old, they will still call themselves 55. So you will kind of put them in here. So again, whenever you're talking about, the life being exposed to risk. So sometimes if that happens and that person turns 56 in a month, then, and all you cared about was for people from 55 to 56, then that person would have been observed only for a month. So from November to December, let's say if their birthday is in January, start. So for that, you need to know the date at which they precisely turn 56. and the date at which, they might turn 55. Or sometimes you don't care about this and all you care about is the start of the investigation. So when did you start your study and when did you end your study? And here the date for exit if there is some censoring involved, and here the date of entry if they enter, in random in between. So these three are the possible things that you can have for the entry and the exit of a particular observation. But again, not all of these three will matter, and not all of these three will matter. What matters is what happens the earliest. So if a person reaches age X, then we'll count that. And if a person reaches, if they already start the investigation, then we will count that. So here as well, whatever happens first is what we count in when we are trying to figure out the central exposed to risk. So let us try to see some example. Okay, what is this? So this is a question. If the age label is age nearest birthday, give the exact age at which a life attains age label X. Okay, so what do you think about this question? So we have already discussed the three definitions of age, right? So if I'm using age nearest birthday, and what is the number that I will say if I'm labeling my age as X? What is my exact age? If I say that my age is X when I'm considering my age nearest birthday. So maybe we will want to go back to the diagrams. So let us see. Yeah. So what the question is actually trying to ask you is, at what actual age do you assign yourself that you are X year old in terms of the age nearest definition? So that would just be X minus half, which is here, right? So this is X minus a half. Because as and when you reach this X minus half, you start calling yourself X years aged, if you're using the age nearest definition. So that is precisely what the question was trying to ask you. So maybe we will go back to the question. Oops, no. We will go back to the question. Yeah. And if you see what they're asking is this, if the age label is age nearest birthday, give the exact age at which a life attains the age label X. So the age label you're trying to use, the age definition you use is age nearest birthday, and you want to call yourself X year old. So what is your precise age? And I know in my denominator here, what I have is my exact age, and this is the age I claim using this particular definition of age. So this is my precise age when I start calling myself X year old using age nearest definition. And that is all that question was trying to ask you. So again, I think these calculations will always be easier if you try to do those number lines and stuff, because then you can clearly see what is the actual age and what will be the age using a particular definition of age, which might be, given to you. And now again, if we are, so again, whenever we try to figure out exposed to risk at a particular point in time, there will be some sort of assumptions. So here they are asking us to note these particular points. So the first is that the calculation takes account of all movements into and out of the population, not just deaths. Why we are saying this? Because again, we know that if a particular life does not die but gets censored, we don't count them in the exposed to risk for the upcoming deaths, right? So we do not only take into account the deaths, but any movement in and out of the population that we are trying to consider. Then the central exposed to risk is independent. Yes, because we don't expect any particular person exiting, affecting the number of, affecting, the information we have about the people who are still there. So it shouldn't be the case as we studied in the Hispanic study, right? So, I mean, if some immigrants are trying to leave when they are very old or when they're on the brink of being aged or being dead, then they're and they go back to their home country. So that does affect the kind of mortality, I mean, the force of mortality for the remaining immigrants, right? And that shouldn't be the case. So we say that whatever happens, the central exposed risk should be independent of the cause of exit for the observation. So that's clear. And then they're saying that, yeah, so again, to be very, very precise and to take into account the leap years, which is when you have one extra day in every year, um, one extra day every 4 years. So what you do is you consider a quarter day extra in each of the years, so that by the end of 4 years, you have one day extra. And you just do that to maintain the accuracy. And second point I skipped, all decrements contribute a fraction of a year in the year of exit, and increments contribute a fraction of the year in the year of entry. So again, sometimes, let's say if I start my study at 1 January 2017, and if some person comes by and joins my study on, let's say even 10th January, then I will consider the fraction that they have spent under the observation. And I will not consider the very first 10 days that they were not there with me. So there is a certain fraction. And again, the same is going to be about the decrement. So whether they are censored or whether they die, if at all they die in the middle of our observation period, then we will consider in the fraction for which they have spent some time being, in the risk. Some time being exposed to the risk of being dead. So this is what they're trying to say in the second point. Okay. And again, so if you take all of these nitty-gritties into account, you can see it's just going to become much messier to figure out the precise estimate. But let us just try to look at this particular example.